Sigma bond and pi bond. The core concept of sigma and pi bond are overlapping. Here, in the case of sigma bond, we can see a head-to-head pairing. It is also known as axial overlapping. In the case of pi bond, we can see a side-to-side pairing. And this side-to-side pair is also known as parallel overlapping. According to the orbital theory of covalency, the bonds formed by the lateral overlapping are weaker than the bonds formed by linear overlapping. So, sigma bond is strong bond and pi bond is a weak bond. Now coming to its reactivity, the sigma bonds are less reactive and pi bonds are more reactive. The stability of sigma bond is high and the stability of pi bond is very low when compared to sigma bond. Now take the case of hydrogen. The electronic configuration of hydrogen atom is 1s1. Suppose the two hydrogen atoms combine to form a hydrogen molecule. The overlapping of s orbitals of these atoms forms a sigma bond. Now let's take the case of oxygen atom. Here the electronic configuration is 1s2, 2s2, 2px2, 2py1, 2pz1. See, we can see that it has got a two half-filled p orbital. So what they do is the p orbital of one atom is linearly overlapped with the p orbital of another atom. So we get a sigma bond over there. So as I said earlier, it has got a two half-filled p orbital. So our remaining p orbital on each atoms are parallel to each other. So what they do is they laterally overlap, form a pi bond. So therefore, in a double bond located in the oxygen atom, there is a sigma bond and a pi bond. Now let's take the case of nitrogen. The electronic configuration is 1s2, 2s2, 2px1, 2py1 and 2pz1. So we can see that it has got three half-filled p orbital in its valence shell. So when two nitrogen atom combines to form a nitrogen molecule, what happens is that it results in the formation of a sigma bond and two pi bonds. Now let's take some examples. Take the case of hydrogen. In hydrogen we can see there is a single bond. So single bond means it is a sigma bond. So in the case of hydrogen there is only one sigma bond. Now in the case of ethylene, we can see there are four single bonds and one double bond. See, as I said earlier, double bond consists of one sigma and one pi bond. So total how many bonds are there? So total we get 5 sigma bonds and one pi bond. And in the last case ethylene, as I said earlier, there is a triple bond over there. So triple bond consists of one sigma and two pi bond. So the total here, ethylene has got 3 sigma bonds and 2 pi bonds.